5b, power reducing and half angles. All right. We actually do use these in Calc BC or Calc 2. So anyway, if you're actually planning on going into that, this you'll see again. All right. So we're going to rewrite sine to the fourth as first powers. Okay, and then we're gonna expand this. All right. Now you don't need to memorize these this year. So anyway, sine squared is equal to 1 minus cosine of 2u over 2. Cosine squared is 1 plus cosine of 2u all over 2. Tangent squared, I really never used that one. So now we have sine to the fourth, and we're going to put these in first powers of sines and cosines. All right, so, yo, dog, they don't go together, so we're going to use this one. We're going to use that one. And sine to the fourth is really sine squared. Squared. Everybody agree with that? Before I go any further, that's what we got to know. All right, and so I'm going to replace this sine squared with 1 minus cosine. So now I end up with 1 minus cosine of 2x all over 2, quantity squared. All right. And so from there, the way that I think is the best method is if I have this as like 1/2 quantity squared is really what? 1/4. All right. So I like to bring out this 1/4. It's going to make your life a little bit easier. And so now I have 1/4, 1 minus cosine of 2x quantity squared. And then we're going to get to FOIL. All right. So again, 1 minus cosine of 2x quantity squared is really 1 minus cosine of 2x times 1 minus cosine of 2x. True? All right. So then when I FOIL that, I'm left with 1/4 times 1 minus what? What's my middle terms going to end up being? Cosine of 2x and then minus cosine of 2x, right? So it's going to be minus 2 cosine of 2x. And then plus cosine squared of 2x. All right. Well, what's wrong with this still? Is it a first power? No. What's going on again? We have another square. And so I need to use this one now. All right, so I need to replace that with that one. All right, so now I'm going to replace it with this one. So then I end up with 1/4 times 1 minus 2 cosine of 2x. And then plus, I'm going to say it's 1/2 plus cosine of 4x over 2. All right, all I did was go ahead and distribute dividing by 2 on this one. That's all that happened here. All right. From there, I like to combine like terms. I think it's a lot easier when you do that. So if I have 1 and 1/2, what do those become? 3/2. They become 3/2. So now I have 1/4, and then times 3/2 minus 2 cosine of 2x, and then I still have plus cosine of 4x over 2. All right. And one last step is now we can factor out a 1/2 from everything here. So if I factor out a 1/2, what's out front? A 1/8. Good. All right, so now I have a 1/8, and then I have a 3 when I factor out a 1/2, minus what? If I factor out a 1/2 from a 2, what do I get? I get 4. All right, 2 divided by 1/2 is 4. So now I have 4 cosine of 2x, and then plus cosine of 4x. And then I am done. Then I'm done. All right. All right. I'm going to help you kind of make sure you're on the right track. Every time you do one of these to a power of 4, you're going to get a 1/8, a 3, a 4, and a 1. All right. As your coefficients. Okay, so that's kind of a check you guys can make on yourself. So anyway, okay. I'd like you to expand cosine to the fourth of 2x. All right. I'm going to get you started. Then I'm going to let you go. Cosine to the fourth of 2x is the same thing as saying cosine squared of 2x, quantity squared. Okay. And so right off the bat, you're going to be using this one. All right. So then you really end up having 1 plus cosine to the what? Of what? 4x. Good. And then it's all over 2 quantity squared. All right. So what could I bring out front? A 1/4. All right, then I have 1 plus cosine of 4x quantity squared. All right, and then we're going to FOIL. So we're back to algebra 1. So now we have 1 plus, what are my middle terms? 2 cosine of 4x, and then plus cosine squared of 4x. All right, but we're not to a first power yet, and so I need to replace this one using that again. And so then I end up with, I still have 1/4, and then I still have 1 plus 2 cosine of 4x. And then, this is, I like to distribute dividing here, so now I have 1/2, and then plus cosine of what? Not 4x, but I double it. So it's 8x over 2. All right. The way that I like to go is I like to combine like terms right here. I think it's just easier. And so now I have 3/2 plus 2 cosine of 4x plus cosine of 8x, still all over 2. And then, what's my last step? Factor out a 1/2. So when I factor out a 1/2, I'm left with 1/8. And then, guess what happens? I get a 3, and now I have a plus 4 cosine of 4x plus cosine of 8x. All right. Again, guess what happened to my coefficients? I still have a 1/8 and then a what? A 3, a 4, and a 1. Every single time you're going to have that. All right. Values. So now we're going to find the exact values of sine of 105 degrees. Again, there's many ways to tampen. I don't necessarily need you to go to one way unless I tell you to use this half angle formula. All right, so I'm actually going to prove this 2 ways to tamper. Is 105 degrees on my unit circle? It's not. It's not on my unit circle. So I guess we can't do it. Just kidding. What is on my unit circle? What if I double it and divide by 2? If I have 210 degrees, what would that actually be? I have 210 degrees. It's right there, guys. What is 210 degrees? 7 pi over 6. That's what it is. All right. So this is actually, I could think of this as like sine of 210 degrees over 2. Isn't that what it is? Isn't 105 the same thing as 210 divided by 2? Yeah. And now I have an angle that I know. Now I know an angle of 210 degrees. So on this one, this is set up as sine of my u over 2. And so I'm going to use this top formula right here. All right. And so I end up having square root of 1 minus cosine of what? What is this u now? 210 degrees. Or how else could you think of it? Because I mostly trained you in radian mode. 7 pi over 6. All right. And then it's over 2. And so I end up having the square root of 1 minus, what is the cosine of 7 pi over 6? Negative square root 3 over 2. So now I have a negative square root 3 over 2. And then it's still over 2 underneath the radical. If I subtract a negative, what's really happening? I'm adding a positive. All right, I'm adding a positive. From here, we kind of need to have common denominators going on. So how do I add things? I need common denominators, right? So how do I think of this 1 if I want to add it to square root 3 over 2? I want to think of that as 2 over 2. And so now I end up having, I still have it underneath the square root, so now I have 2 over 2 plus square root 3 over 2 all over 2. Right? Well, so now I can actually add them together. So then I end up having square root of 2 plus square root 3 over 2 over 2. Well, if I divide by 2 and then I divide by 2, that's really dividing by 4. It's really dividing by 4. And so I now end up having the square root of 2 plus square root 3 all over 4. I personally am okay with it right there. However, this 4 is a perfect, so it is actually allowed to come out of the square root. All right, so then I could also say it's just the square root of 2 plus the square root of 3 all over 4. So you have a radical inside a radical. All right, and that is the exact answer of sine of 105 degrees. All right. Thank you. All right, yes, that is 2. My goodness. I'm going to leave that on there. How can I get to 105 degrees with angles that I know? What angles do you know? You know 90, okay. What else do you know? You know 30. You know what? You know 60. What else do you know? You know 45. Can any of those things happen to get to 105? 60 and 45. So let's do that. So now I end up having sine of 60 degrees plus 45 degrees. Remember doing that sum and difference formulas? So if I look at my little reference sheet, which one am I going to use? I'm going to use the first one. So now I'd end up having sine of 60. Okay, you want to do pi over 3? That's fine. Sine of pi over 3. And then cosine of pi over 4. You see how we're just using that first one on our reference sheet. And then plus cosine of pi over 3. And then sine of pi over 4. All right. And so now I can evaluate. So what is the sine of pi over 3? Square root 3 over 2. And then what's the cosine of pi over 4? Square root 2 over 2. And then what's the cosine of pi over 3? 1/2. And then what's the sine of pi over 4? Square root 2 over 2. All right. So then when we multiply them together, my common denominator is going to end up being 4. And so I'd have square root 3 times square root 2, which is square root 6. And then plus square root 2. All right. So now I have square root 6 plus square root 2 all over 4. Well, look at that. All right, let's do this one. So now we're going to find sine, cosine, and tangent of 3 pi over 8. Is 3 pi over 8 on my unit circle? Is it? It's not on there. Just guess we can't do it. What angle is on my unit circle? If I double something, what would it be? If I double that, what would it be? It'd be 6 pi over 8, right? Which we know is 3 pi over 4. So 3 pi over 8 is the same thing as saying 3 pi over 4 divided by 2. And so that is how we can actually use our half angle, because I know 3 pi over 4. Do I not? All right. So now we can actually utilize these formulas. All right. So let's do sine. So now we're going to do the sine of 3 pi over 4 over 2. So I'm going to use this top one. So now I end up having the square root of 1 minus cosine of 3 pi over 4 over 2. Well, what is the cosine of 3 pi over 4? Negative square root 2 over 2. Good. All right. So then I end up having negative square root 2 over 2. But I'm subtracting it. Now I kind of want to save some time. What do I really want to think of 1 as? I want to think of it as 2 over 2. Let's find common denominators right away so we work smarter, not harder. All right. And then it's still over 2. Okay. So then I end up having the square root of 2 plus square root 2 all over what? All over 4. All over 4. Now, if I want to get it outside of my radical, what could I actually make it? Square root of 2 plus the square root of 2 all over 2. Okay. All right, now let's do the cosine. So cosine of 3 pi over 4 over 2, which is equivalent to 3 pi over 8. That's really what we're doing. So now I end up having the square root of 1 plus cosine of 3 pi over 4 all over 2. Well, what is the cosine of 3 pi over 4? Negative square root of 2. All right, again, how should I probably think of this 1? 2 over 2. And then I have minus square root 2 over 2. And then it's still all over 2. And so I end up with the square root of 2 plus, not plus, 2 minus square root of 2 all over 4. And then if I wanted to, what could I bring out? I could bring out a square root of 4, which is 2. So now I have square root of 2 minus the square root of 2 all over 2. All right. Now, on tangent, I never used that one. What would I do? Do what? Sine over cosine. All right. It's going to look a lot different than CalcChat, but just put sine over cosine. So now I have square root of 2 plus the square root of 2 over the square root of 2 minus the square root of 2. All right. And then I am good with it right there. Okay? There you go. There you go. First one, we use some trig identities to see which ones are true or not. This one, you might need to use a double angle, solving for exact solutions. This one's using a multi-angle equation, solving for solutions. What's the period of sine stuff? What's the period of sine, cosine, those things? 2 pi. What's the period of tangent and cotangent? Pi. So you add in pi's, 2 in pi's, those things. All right. Which of the following is the solution to the equation? Again, get a trig function equal to a number. This one's very similar to something that we went over today, like 33. Then this next one, use a half-angle formula to determine the exact value of the following, just like we did on our notes today. Given two trig functions equals numbers, evaluate all 6 trig functions. So you're going to draw a triangle, basically, and go from there. Very similar to things on your quiz. Use trig fundamental identities to simplify the expression. All right, solve an equation. Again, get a trig number equal to, get a trig equation equal to a number. This one's one of those longer ones where you have to use sum and difference formulas twice to then solve the equation. This one's finding sine of 2u, cosine 2u, and tangent of 2u. Very similar to what we went over on Marley's problem. All right, this is part 2. Simplify the given expression algebraically, again, using sum and difference formulas. This one, use trig substitution to write a function as theta. That's very similar to that top one on the back side of your quiz. This one, use half-angle formula to simplify the given expression. So again, very similar to 33. You're kind of just using your formula, seeing how to work it. All right. This next one, all right, rewrite the expression that it's not in fractional form. Very similar to those that we did on our homework and our notes. There we go. Find the exact solutions of the given equation. You might have to factor on that. All right. Use a double angle formula to find the exact value. Again, draw the triangle. All right. Next one, use the power reducing formula to rewrite the expression in terms of the first power of cosine. All right. It's either going to be sine or cosine to the 4th power, and it's either going to be a 1x, a 2x, or a 3x. All right. It's going to be one of those 6. All right. The next one, use trig expressions as an algebraic expression. It's going to be a trig function, then an arc of this, plus or minus an arc of that. So you're going to use your sum and difference. as well as draw your two triangles, your U and your V triangles. Go back and look at your notes. The next one, solve an equation. Solve for all the answers. And then the last one, I hate grading, verify the identity shown. All right, so you're going to use probably Pythagoric identities and going on that way. All right.